Good morning, good afternoon, and good evening, wherever you are in our virtual world. My name is Ron Dagdag. I am a software engineer at Spacey. I'm also a Microsoft MVP. Today, I will be talking about developing Spidey Senses anomaly detection for apps. All right. Spidey senses. If you're not familiar with Spider-Man, I hope you are, because most likely you've watched some of the videos, the cartoons, the comics throughout the years. And what is a Spidey sense? A Spidey sense is that tingling sensation in the back of Peter Parker's skull. Peter Parker is the character that portrays Spider-Man, and it helps him that ability to sense danger or react to it. It increases his ability to be able to detect evil in clones, which helps him navigate and kind of see where he's at and helps him fire his web shooters, all the different things that Spider-Man makes a Spider-Man is the Spidey sense. And of course, the real spider sense is, it's the real spiders have this hyper awareness where, notice that these long thin hairs, they call trichobothria. And what it does is it helps detect lower level vibrations through their web and be able to detect even sounds because that's how sensitive it is. And even, insects, even up to small 3 meters away. So it's amazing creature and having that spidey sense. And of course, if you're a new web developer and it feels like, hey, here's my website, and trying to cast your skills out there, and that's how it feels like being a web developer. Especially if you're starting out. You haven't. What I'm saying is that you haven't built your spidey sense. What is a spidey sense? It's that gut feel and vibe, and in a way, for humans, for us, it's that feeling, that intuition. It helps us discover the blind spots, and how we build that skill is through what we learned from the past, about the years. Of course, on in the software side, there's low-level programming language and compilers and high-level programming languages. For us, we'll be talking about this instincts and intuition, right? And that's what we define the spidey sense. That sometimes you don't. And then of course you have the interpreter module that would give you insights. Insights. If you think about the the part of the brain where your conscious brain and subconscious brain. So we're thinking about the subconscious side of things, which is the spidey senses. Today, we'll talk about anomaly detection, uh, and then we'll work through the time series anomaly detection, and then we'll do some demos and some takeaways related to that. Anomaly detection is kind of like Spidey senses, right? It helps us identify unexpected items or events in our data sets, which is different from the normal. Yeah. If you think about these days, we're having our conferences virtually. We typically meet in person, and so this is weird. It's an outlier. Hopefully next year or later this year we'll go back and we'll be able to do in person. I really miss in-person conferences. It's when I talk to other developers, is where I be able to discuss and have different conversation and and learn from other developers. And that's what's interests me in doing and presenting at conferences. So going back to anomaly detection, uh, it's an outlier, data anomalies. The assumptions are that anomalies only occur rarely in data. It doesn't happen every time, and their features are different from the normal instances significantly. So what are two causes of outliers? It can be, artificial or non-natural or natural causes. Artificial could be, data entry errors, 100,000 versus 1 million, an extra zero makes a whole lot of difference in terms of data. It could be measurement errors where you have, and which is very common. right? Where you're measuring in different units of measurement. And of course, experimental error. That's when you start collecting your data late in the sprint rather than you know, balanced data. Intentional outlier would be something sometimes like, you know, we talk about underreporting of alcohol consumption for underage uh, kids. You know, it's a more intentional side. Data processing error would be more extracting from one data set to another data set and how you that can cause some problems. Sampling errors. This one is where you're trying to report the height of all the athletes, but a lot of your data set is more basketball players, so it's skew against that, towards that. Natural outlier when it's not artificial, it happens. Sensors or data sets. The stock market can have an outlier too. So what we're trying to do here is you have a data stream, you have your data, and mixed with some of it is defective, some of them is good data, and you're trying to identify, is the data that you have, you know, anomaly or not, right? Anomalous or not. So of course there are some instances that you may not be able to detect if it's defective, the defective ones. But hopefully our goal is to detect as much as we can. But sometimes also you might detect things that may not be anomalous, but you detected them anyway. So that's a possibility. So it's not an easy problem to solve. It's kind of like finding a needle in a haystack. If that needle is that big, yeah, it's there. It's easy. Uh, so today we'll talk about different methods and how we can create anomaly detection systems, right? So it could be rule-based, it could be statistical techniques, it could be machine learning. Rule-based, most likely you do this already, where you specify different rules, right? If the temperature of your house is certain limit or certain threshold, send an alert, you know, or goes below a certain threshold. Um, the advantage of it, or disadvantage in a way, is that you need an experience in the industry, or to detect the known anomalies for an existing system, right? So that's when you kind of talk to your users or talk to industry expert, the one that knows more about that system, and let us know when does this anomaly happen, those kind of things. The disadvantage is it does not adapt to pattern changes. You know, through time, uh, the environmental changes can have impact, right? And then, of course, data labeling. You have to kind of label your data if it's anomalous or not, those kind of things. So that's the disadvantage of having a rule-based system, but it's easy to implement. Another one is through statistical techniques. And you see that in the stock market where they use a lot of statistical techniques where sometimes even your sales data, they do the mean, median, or mode. Sometimes they'll do rolling averages or moving averages. Even sensors these days, they may have some low pass filter, for example, some Kalman filters to reduce the noise. And a noise is considered an anomaly, right? Uh, it could be also histogram based or outlier detection. The advantage of statistical techniques is it's easy to show the formula to someone and interpret it as compared to a machine learning method. Of course, we're talking about machine learning method. It could be supervised, unsupervised, self-supervised. So to detect anomalies, you can use decision trees, or do some forecasting. K-means for the unsupervised, or hierarchical clustering. You can also do self-supervised. That's when you use the LSTM autoencoder. We're not going to focus a lot on these different types, but I wanted to kind of talk to you. When do you use anomaly detection algorithms versus supervised learning? Supervised learning, hot dog, not hot dog, those kind of things. Uh, so anomaly detection is very good if you have a very small number of positive example and a large number of negative examples. Uh, as compared to supervised learning, when you have large number of positive and negative examples. So meaning you have your data set have an equal number of examples. Of course, if there's enough positive examples for the algorithm to learn, so if you only have few examples or it rarely happens, the supervised learning techniques may not work. The advantage of anomaly detection, uh, when the future anomalies may not have been discovered yet. So there are things that most likely, you know, you haven't kind of explored your data set, and so you might want to look into anomaly detection techniques rather than the supervised learning. Uh, this on the supervised learning side, when the future positive examples is likely similar to the training set. So those are things you have to consider, which algorithms you might want to. So anomaly detection would be good if you're talking about fraud detection, or in manufacturing, you have a machine or an engine, goes back and forth, or you have a robot, it has its own path, and then when it goes out of its path, yeah, it makes sense to do anomaly detection on that. Monitoring a data center, you have a machine that's running throughout, so, and that would be a good example of doing anomaly detection, especially on the Internet of Things, in which we'll talk more later. For the supervised learning, when you talk about email spam classification, why is that? Is because there's a lot of examples of spam that you can classify. Weather prediction, there's also a bunch of examples for weather prediction. Of course, I live in Texas. Sometimes our weather is kind of weird sometimes, uh, but it can be predicted. And of course, cancer classification. Why cancer classification? Is because you have experts in the field that they know what they're looking for. You have the specialized skill, a specialized person that looks into what are different cancer classification. So machine learning, it could be density based, that you can do anomaly detection that way. It could be cluster based. That's when you talk about k-means, where it tend to belong to clusters. So you look at your data set and are they clustering, and then you can use that as anomaly. Anything outside of that cluster would be anomalous. It can also be Gaussian distribution, where you calculate the Gaussian distribution of what is normal, and anything outside of that normal would be an anomaly, right? A certain threshold. It could also be support vector machines, where you kind of split your data into two. One side would be the normal side, which is, and then the anomalous side would be on the other. So you're trying to figure out where that boundary is, that you can use support vector machine. PCA-based anomaly detection also can be used, which is another way to do distance metrics. And the advantage of that is it's faster training. I'm going to focus more into the time series data at this point, because I think it makes sense for us to do time series data. What is a time series, especially on anomaly detection? Time series data is where you have a series of data points that are indexed with time, right? With time order. The good examples of that, you see it every day. You turn on your TV, CNBC, there's always that time series data set. It's called the stock market. And of course, if you work for someone, there's always that sales data, the invoice and sales data, and also the inventory data. There's always that time series data set that you have to deal with, especially if you're working with Internet of Things, you work with sensors. There's that time series component of of that sensor. So any data captured with a timestamp is a time series data set. So for Internet of Things world, the reason why Internet of Things is happening is because of the data volume. The sensors are getting cheaper. It's easier to collect data, and also the data speed. The way we transfer that data has been improving, but the advantage also can be a disadvantage, because of the risk are becoming very you have more data that you're collecting, but failures are not being tolerated. There's more and more things that is integrated, not just in our home, in factories, and at workplaces, that it's becoming critical, these Internet of Things devices. And of course, if you have something uh, that is broken, especially in the Internet of Things world, it feels it's harder to kind of figure out where it's coming from and what's going on, right? So that's when we talk about the artificial intelligence of things, where we collect our data in our gateways or our applications, where you have real-time devices and sensors, and then be able to trigger, right? Uh, anything outside of its norm, or send something up to the cloud to where you have your device twins, and then of course you have your business intelligence, and all your dashboards tracking these devices. So if you think about it, if you have your applications, your cell phone applications, you can track it this way too. It could be considered as an edge device. So time series anomaly data types could be an outlier, spike and level shift, and pattern changes, pattern change and seasonality. I'll talk more related to that. Outlier would be something like, you have your data, your time series data, there's a time component, and of course your data set, and then suddenly it spikes up. That can be, that's considered an outlier. Another one is spike and level shift, where you have, your data set, right, coming in at certain, and then suddenly it leveled up or it shift. So that can be considered an outlier. What happened there? So do you want to trigger, or and know that uh, when that happens? Another one is pattern change. Easy example here is you have your water hose, and someone, you're watering your garden, and someone stepped on that water hose, and suddenly all the water that's spitting out, it was reduced. And what happened? Do you want to get tracked, or be able to uh, alerted on that one? So that's a pattern change. And of course, seasonality. You have to consider seasonality whenever you're working on a time series data. A certain time of the year, during summer, of course, if you're talking about sales data of ice cream, it's summer is where there's more, and then of course less during winter time, those kind of things. Of course, unless you know, you unless your favorite food is ice cream, so your sales might be up. But it's seasonality. You have to consider seasonality towards your data if you're doing anomaly detection. Of course, we talked about production issues. Whenever there's something going on, you have a series of uh, data flows, and you feels like you're stopping the train. That's how it feels like when you have production issues. So wouldn't be good to know and implement these. Uh, so what I'm talking, just to kind of give you an example of what I'm kind of talking about here, where you have your manufacturing data, you have a machine that's running back and forth, and then of course, you have the usual data, and you're going through the time series and trying to understand based from that. And of course, as it flows through your data set, and notice how here it detected, hey, that one is an anomaly. And so trying to understand this and how sensitive you want it to be, right? So those are the things, especially if you have streaming data. And of course, the kind of based from this historical information, identify at that certain point in time, is there an anomaly or not? Okay, so this one right here is a good example on how you can visualize, and also at the same time uh, alert and identify anomalies. The time series anomaly detection, typically you would do identifying spikes, which are temporary burst, or change points, which is the level changes and trends. So in Azure world, how you would do it, of course, if you're on the edge devices, you might want to work with ML.NET to run inferencing on that to run your anomaly detection. And of course, if you're streaming data to the cloud, of course, you might want to do Azure Stream Analytics to be able to do anomaly detection on the data set that gets streamed. And of course, your dashboard, Power BI, or might want to use Azure Cognitive Services to be able to do anomaly detection there too. So today I'll talk about all these different things. So ML.NET, it's for .NET developers that has C# and F# skills and want to include anomaly or machine learning to their pipeline or to their the advantage of this is not required to have a data science or machine learning experience, because there is a time series catalog that you can include to your application. So you can detect anomalies. There's using some of the pre algorithms that they have or implemented algorithms. So what it looks like. So today I'll focus on this detect IID spike and kind of show you how you can use this using ML.NET, and we'll do some demo on that. All these is going to be on my GitHub, so I just want to kind of show you what my data looks like. My data looks like this, so I have 6 columns. All of them are string. So where you have your comma separated values, where you have these data set, which is the temperature and also humidity, and of course it's time series data. This is the data that I collected around that time, right? And then it goes up to the end. Notice how my data set at the end part of it is kind of does not have complete data, or it notice that the temperature did increase a little bit, so from 27 to 124. So what we want to do is when this happened, we want to detect, hey, there is an anomaly around that time. So when I run the application, just want to show you the output. So it goes through a series of data set as it reads that data set, and at the end, when it detected an anomaly, this is the data set, and it kind of identifies, hey, from that point in time, there's an anomaly in your data, and then there's that spike that was detected. So how did I implement this? Let's go through the code. So on my project, in order to do ML.NET, there are two things that you need to add to your project, NuGet packages. There are 2 NuGet packages, Microsoft.ml and Microsoft.ml.timeseries. This allows you to be able to access the time series catalog. So after you include that, we'll go to the program, go through here. See if I can close this. So what I'm doing here is I'm mapping my CSV file to a class where you have your input temperature, humidity, and it specifies which column I want to share or I want to be able to see, and then the timestamp. And then on here, I'm converting it to a float. So how I converted it to a float. So in order to use ML.NET into your application, the critical part is using using Microsoft.ml and using Microsoft.ml.data. So once you have that, going back to the initial application. So this is that part where I'm reading my CSV file, and ML context is part of Microsoft.ml NuGet packages. So that's how you would do that. So this is where you would be able to access how you load from the text file in this case, or how you do your transforms and convert. So there's the important part here is what I'm trying to get at, is most likely, feel free to write it out on your own. The important part here is just in order to implement anomaly detection into and using that ML context, is you access this ML context that transforms, that detect IID spike. you pass in 4 values. The important part is, this one is, since a time series data, so you need 2 things, right? The input, where is the time input, and then of course, where do you put the output column? And then based from that, you specify, look at the previous values of your data set, like in this case, looks at the last 25 items of your data set, and then what is the confidence level? And then based from that, so the confidence level is how sensitive is your anomaly detector, right? The anomaly detection system. And then you will create an estimator for you. And there's always that 2 things you have to do. You have to create fit and transform, right? So fit, you pass in like in this case, the advantage of using this anomaly detection algorithms is that you don't need to do pre-training, right? It looks at the previous data set, right? The historical data set to be able to detect this. It looks at the last 25 items on your list to detect if that item is a spike. So you don't need some training data or anything else to pass in. So this one, it's passed in the blank data view to create the transformer, and then based from that transformer, you pass in your data that you're trying to detect anomalies, and it would create this transform data. And then based from that transform data, you can use it to do the prediction, and then display the predictions. The predictions, there are 3 things I believe that it needs. Let's go back here. So you have so in this case, it's an array of double, where it would hold the alert, the score, and the probability value. So that's how you would do this. Okay, so that's just a quick introduction. Feel free to read more about related to how you would use it in ML.NET and run it locally on your machine. Okay, let me go back to that presentation right here. Let's see that, because I have about 10 minutes left. For Azure Stream Analytics, it's where you send data up, log files or customer files, send it up either Azure Blob Storage or IT Hub or Event Hub, or you have streaming data, and you can have Stream Analytics be able to ingest that or process that data. And of course, you can either do Azure ML services to be able to hydrate and call and be able to run real-time or continuous intelligence or real-time analytics. And then of course you deliver it using alerts or actions, using be there Azure functions, doing Azure in Power BI, or how you would deliver that data set. Azure Stream Analytics has some functions, how you can do anomaly detection, and this is the key part of it, is where you have anomaly detection underscore spike and dip, and you pass in pretty much how you would kind of do the anomaly detection in ML.NET. You need a few things, your sensitivity. So like in this case, 95% is my sensitivity. And then of course, 120, that means 120 items, historical items from your data set. In this case, it looks at the duration, 120. So since you're receiving in Stream Analytics, you're receiving the last 120 seconds, or you're receiving data, and what this one tells you is that look at the last 120 seconds of the streaming data, and only look at the last 120 seconds of your streaming data, and then be able to map that and be able to get the score and if it's is anomaly or not. So that is one way how you would do spike and dips. Change points, kind of like the same way. So there's those 2, anomaly detection underscore change point as part of these MuSQL. As you receive your data, as you process your data, create another, in a way, as another table called change point scores that would look at the last, in this case, the last 20 minutes, and look at the sensitivity is 80. And in this case, I'm looking at 1,200 data points, and looking at a certain column based from that, create a score, right, and an anomaly. So I am not going to demo these because it takes a long time to set up, and we only have a few minutes left in our presentation. But what it's doing is what how you would see it is you can ingest the data, send it to from your sensor to, or from your application to blob storage, or through IoT hub, and then from IoT hub you stream analytics, and you can do some real-time scoring, and then deliver it using blob storage, or in this case you can do it using Azure functions, or however you want to deliver that alert. Another way is through Azure Cognitive Services, where it's just an API call, right? Azure Cognitive Services have different um, different capabilities, or different ways in how you would call those APIs. One of the APIs is using this decision, and there you have personalizer, content moderator, and of course we're going to talk about anomaly detector, where you can identify potential problems early on. So anomaly detector, as part of cognitive services, it can detect it as a batch, or you can detect it as real time. You can also adapt and learn, it automatically adapts and learns from new data as you receive it. And of course, you can do fine tuning for sensitivity. It is just a REST API, so it does not, no need for machine learning expertise. It builds and figures out the correct algorithm, or the best algorithm that you can use based from the data set that you send it. And it eliminates the need for training data, and identify the best fitting model for it, and how it's running in the background, right? There's a series of algorithms that's already pre-implemented for you. And what it does is, if you send and call this API based from the data set that you sent, it figures out, hey, does your data set have seasonality? It would use different kinds of algorithm. If it has coarse granularity or without seasonality, it would use different set of algorithms on the fly for you. So it's great. It simplifies the problem. There are a few limitations in how, when you call anomaly detector, it could be, you have to specify based from your data set, is it daily, hourly, minutely, monthly, weekly, yearly? So those are uh, only capabilities that it data set that it can receive. It also a minimum of 12 in, from your, like in this case, the data set on JSON payload, up to 8600, 8640 entries. So your entries, your data set had to look something like this, where you have the timestamp and the current value, the timestamp and the current value. In this case, I specify this data set is daily. And if I want to have a custom interval, like in this case, every 5 minutes, if my data set is every 5 minutes, you can specify it like that, right? Where you specify custom interval, and of course you can you can plug in your data that way, or send the data properly. How you would call the anomaly detector API? There's two ways. You can use the client SDK, which is implemented in C#, Python, or Node. If the programming language that you're using does not support, that does not have a client SDK, of course you can call REST API. So that means any language that supports any HTTP calls you can use. So let's do some demos in a few minutes that we have here. So I have, see if I can go back here. Okay, I have my, here is my Raspberry Pi. On top of my Raspberry Pi, I have a another sensor that would display LED. That's called the Sense hat on my Raspberry Pi here. And and also be able to detect temperature and humidity. So what I did on this application, I'm running, I'm logged into that. I did install on that Raspberry Pi Jupyter, and it's using TypeScript. I installed TypeScript Node on that machine, and I'm trying to connect it. I'm connected through my browser to that Raspberry Pi to send some commands. Like in this case, if I want to send hello world, I can send it through the browser and it would run in the Node application in the backend using Jupyter Notebook and with the TypeScript as its kernel. So in this case, I did run it. I'm using TS Lab in order to do this, which is that allows me to have a different kernel other than Python. I can use TypeScript in Jupyter. This one right here allows me to be able to connect to the Sense hat, to that sensor that I have on that machine. And then, of course, if I want to clear it, and if I want to get the accelerator data or some data set from my machine or from my application or from my device, I can get that here and be able to get some data, right? So what I did here is set it up to where every few minutes it will connect to all these, right? And connect to all the timestamps and all these timestamp values. And I was able to, run and get the timestamp value. And then, and what I did here is to create the instance of the anomaly detector. And then based from that anomaly detector, I was able to call the API, and based from that API, I was able to connect and see, pass in that same data set using that API, and then the item, it would tell me if it's anomalous or not. So in this case, so what I'm doing here, which is if the item on my list is anomalous or not, it would set the pixel. It would specify if there's anomalous. So I would like to demo that real quick. I want to run this application just to kind of show you what it's going to look like. Right here, sorry. So last part of my application here. There you go. I don't know if you can see that the machine lights up because at the last part of it, it was detected that the last item on my list, calling that anomaly detector API as it requests back, that is anomalous or not, and then I set the pixel and send the alert. Cool. So that's a quick demo. I only have a few minutes, so I don't have a lot of time to be able to kind of discuss more, but at the end of the day, you're calling a REST API. So where you can use this, you can use C#, JavaScript, and Python, or through Docker containers, Power BI. You can use it through Databricks for streaming data to call the REST API. There's also Metrics Advisor, which I recommend you all using or to kind of look into. Metrics Advisor is also part of Azure Cognitive Services. What it looks like at the end of the day, what it's trying to do is, right, it's a portal where you can collect time series data and visualize that and detect anomalies from inside that portal. And then when there's something wrong with the anomaly, you can send incident alerts. And then if there's an alert, it kind of points you how to analyze the root cause where that's coming from. So I would recommend you looking into that. The best superpower that you can give to your application is a Spidey Sense, which is anomaly detection. So if you want to learn more about me, my name is Ron Dagdag, and thank you very much. Any questions so far? This is the link to the presentation if you are interested in learning more. and try out the demos. And the best way to contact me is through LinkedIn or Twitter at Ron Dagdag. And I appreciate you geeking out with me, talking about Spidey senses and anomaly detection.